Welcome to Introduction to Data Science. In this lesson, we'll uncover the basics of what data science is, how it works, and why it's so vital in today's data-driven world. Think of it as the groundwork for everything from customizing your social media feed to predicting natural disasters. Our goal here is to help you see data science not just as a buzzword, but as a powerful tool for solving real-world problems. By the end, you'll understand the core concepts and be ready to dive deeper into this fascinating field. Data science is the practice of turning raw data into meaningful insights. It blends statistics, computer programming, and domain knowledge to find patterns and make predictions. Imagine having thousands of puzzle pieces scattered around. Data science helps you piece them together to form a clear picture of trends, behaviors, and outcomes. In this scene, we'll look at a simple diagram of the data science Venn diagram, highlighting the intersection of coding, math, and subject expertise. This intersection is the heart of data science. Stories drive home the value of data science. Consider a grocery store chain that struggled to predict inventory needs. With data science, they discovered buying patterns, optimized restocking schedules, and reduced waste. This not only saved money, but also increased customer satisfaction. In businesses worldwide, data science pinpoints inefficiencies, forecasts trends, and personalizes services. Picture a circular diagram showing stages: data collection, data cleaning, exploratory data analysis, EDA, modeling, and deployment. Data scientists begin by gathering information from multiple sources, then ensure the data is accurate and consistent. Next, they explore it. This might involve plotting graphs or searching for correlations. The refined data feeds into statistical or machine learning models, generating predictions or insights. Finally, these insights are deployed into real-world systems, whether that's a recommendation engine or a forecasting tool. Data collection is the starting block. You might retrieve information from websites, internal databases, APIs, or even public datasets. For instance, if you're studying climate patterns, you could pull historical temperature records from a weather agency's website. In a business setting, data could come from sales transactions, customer interactions, or sensor readings. Once data is gathered, errors, missing values, and inconsistencies must be addressed. Think of it like editing text, removing typos and ensuring clarity. Skipping this step can lead to misinformed decisions. For instance, in healthcare data, a single error in patient records could skew important research outcomes. Visually, you might see a short table that highlights rows with incorrect or missing entries. Good cleaning lays the foundation, ensuring that every subsequent stage yields valid and trustworthy insights. EDA is about getting to know your dataset. It involves looking at distributions, relationships, and outliers. Suppose you have a dataset of global sales figures. You might chart monthly sales to spot peaks or valleys. Scatter plots or box plots are common ways to visually inspect data and find trends or anomalies. During this stage, data scientists often generate hypotheses and refine their questions. By investigating patterns, they're better prepared to choose the right analytical approach in the next stage, building predictive or descriptive models. After understanding the data, it's time to build models, algorithms that help make predictions or classify information. Examples include linear regression for forecasting sales or a classification model for detecting spam emails. Imagine a line chart showing predicted versus actual sales over time. The closer they match, the more accurate the model. While some models are simple, others, like deep learning frameworks, can be highly complex. Regardless of complexity, the goal remains. Use historical patterns to make educated guesses about the future or to categorize new information. Once a model is developed, it has to be put to use, known as deployment. For instance, a recommendation system on an e-commerce site might rely on real-time predictions to suggest products. But deployment doesn't end the story. Ongoing monitoring ensures the model adapts to new data and remains accurate. Continuous evaluation is crucial because data, customer behaviors, and market conditions evolve. Data science is never a set-and-forget process. It's an ongoing cycle. Netflix famously uses data science to recommend shows and movies you might love. By tracking viewing habits, ratings, and even how long you pause, their algorithms personalize your homepage. This technique boosted viewer engagement and retention. By blending large data sets with machine learning, Netflix keeps users hooked. This real-life success story shows how powerful data insights can enhance user experience, increase profits, and transform an entire industry's approach to content delivery. In healthcare, data science aids early disease detection and personalized treatments. Hospitals collect patient records, lab results, and imaging data, then analyze them for patterns. For instance, a predictive model might flag potential heart issues by examining vital signs over time. Such insights help doctors intervene earlier, improving patient outcomes. This time, showing a simple bar chart comparing hospital readmission rates before and after implementing data science solutions can highlight the dramatic improvements in care and cost savings for both patients and providers. There are countless online repositories where you can find data sets for practice or research. Kaggle, UCI Machine Learning Repository, and Data.gov are popular choices. We can display website screenshots of Kaggle's homepage, highlighting how data sets are categorized by topics, from finance to healthcare. Many of these sources provide user-friendly interfaces and community forums to discuss findings. Working with real data is the best way to build skills and confidence. Remember, the key is to look for reliable, well-documented, and ethically sourced data. Data science underpins modern AI. AI systems, including machine learning and deep learning, rely on large, high-quality data sets to learn patterns. Imagine a voice assistant that improves over time. Each user query is new data feeding the model. Data scientists refine these models to be faster, more accurate, and more adaptable. By bringing domain expertise and rigorous analysis, data science ensures AI systems serve real human needs. We've journeyed through the definition of data science, its life cycle, and practical applications, from grocery inventory forecasting to Netflix recommendations and healthcare predictions. Key steps include collecting trustworthy data, cleaning it thoroughly, exploring it for trends, building predictive or descriptive models, and continuously monitoring those models. Tools like charts, diagrams, and dashboards help visualize progress, while real-world case studies highlight why data science matters. By understanding these foundations, you're better equipped to see how data science fits into AI and drives business success. Armed with basic data science knowledge, you can make smarter decisions in any field: healthcare, finance, retail, or tech. In business, data science can lower costs, boost sales, and drive innovation. For individuals, it can mean better healthcare outcomes or personalized recommendations that simplify daily life. The ripple effects are vast, from optimizing city traffic flows to fine-tuning climate models that save lives. By appreciating the real-life impact, you'll see how data science isn't just a tool. It's a gateway to a more informed, efficient future.